Hi folks, Dr. Pingel here. It is August 15th, and this is my last summer update, I expect. Looking forward to seeing everybody back in the office soon. This was kind of a random one, but there was an article in wherever, phys.org, talking about a new article in Nature about color spaces. So this is interesting. The authors claim that the current models for perceptual color space are not correct, and they are proposing a new one. I don't think that they get as far as proposing an actual new one. I think they just say that a new one needs to be created, and they have evidence that the old one is not sufficient. So this will be an interesting thing to keep track of. One minor X-Ways update. And that is Hassan, the CEO of X-Ways, and I have been in touch, and he provided some sample data that we can use to get X-Ways running. So getting X-Ways up and operational is kind of on my last summer shortlist. I'm hoping I'll get a chance to try that out this week. I spent some time on PDAL. PDAL is the Point Data Abstraction Library. What I did was create a PDAL recipes repository. I populated it with just a couple of things. This is the first thing. This was a way to change NumPy arrays into and save them as LiDAR files. So why might you want to do this? You might want to do this if you've been working with LiDAR arrays of various kinds. It was not intuitive as far as how to package the XYZ data. So I spent an afternoon sorting that out. This is what it looks like. Essentially, the gist here is you need to supply tuples, an array of tuples. So this is what that code might look like. Here I'm just creating some random X, Y, and Z data, some intensity data, and then storing that. And the gist of it here is at the bottom, right before the pipeline execute, is where the array of data is being passed. And you can see that I've got to zip the XYZ and intensity arrays together into tuples, change that into a list, and then give that to a NumPy array. Looking at this, I have a feeling probably either NP array or list is probably not necessary, but maybe they were. I did this last week, so I can't quite remember if I had tried that or not. This is just a demonstration that worked. I did a video, this is going to lead back into PDAL here in a second, but I did a video walking through the new method of classifying point clouds in Cloud Compare. There's a new tool, which I had mentioned, I think, in a previous lab report, in which you can use the segmenting tool, the scissors, grab things with a polygon, and then declare those as a certain type. You have to be a little careful with it because it works fast, maybe a little bit too fast. Once you basically hit enter on the number, then it's done. That's probably a good thing, but you do have to be pretty careful about it. The rest of that interface sort of has like a checkbox or abandoned changes, but this doesn't have that. So once you've done it, you've kind of done it. So you have to be a little bit careful. I've just pasted the classification values here, and this is just an example of a quick ground filtering run on a Blacksburg LiDAR tile. I updated Smurf while I was doing this. I'm sort of keeping an eye out for releasing Smurf 2 at some point. One of the things that I think is likely to be helpful is when points drop out of the classification stream. So Smurf is what's called a progressive algorithm. It iterates through on a couple of expanding window sizes. And so things sort of shake out sort of like different sizes of filters in a sieve or something. And things sort of shake out at different points. And so I have a a feeling that certain parts of this are going to shake out faster than others. One of the things that I noticed that I wasn't totally expecting was that the trees don't actually shake out in this way at all, and the reason for that is it took me a little bit for this to sink in, but Smurf works with a minimum filter as a beginning, and oftentimes that minimum filter alone is enough to get rid of many of the trees, and so they never actually get classified. The cells that they occupy never get classified as objects as you move through Smurf. So it's kind of an interesting, maybe they would if you ran a much smaller filter, or sorry, a much smaller mesh. I don't know. I'll have to give that some thought. But hopefully this will help. I changed the syntax here a little bit. This is not going to affect anybody probably except Beth Pryor in Cully Hession's lab, who's been using the return above ground height flag. I've removed that and I've added return extras, and this lets me be, a little more developmental in terms of how I add features like that. I can just basically add them as part of the dictionary. So this gives me a lot of flexibility moving forward. It's probably what I should have done originally, but I'm excited about it. I think this is a nice way to add things in. The other thing that I did was play around with PDAL's translate function. So translate is a neat. I don't know that this was around when I first started playing with PDAL. Maybe it was, maybe it wasn't. But what it does is it lets you specify an input and an output, and then basically a pipeline of processing through a JSON file that you declare. Now, the neat thing about this, that the previous syntax for this would have been like PDAL pipeline, and then you just give it a JSON file, and then you would declare the input and output in the JSON file. But the thing that's really neat about this is that it lets you use the same processing pipeline on different inputs and outputs. So this is an example of a classifier that I wrote that basically, it consists of a couple of stages. So the first stage assigns the classification values to 0, so it erases any previous classification. It runs through Smurf. It calculates the height above ground. It then assigns, so Smurf will assign things as like ground and not ground. With the height above ground calculated, you can assign, so I'm assigning an 18, which is high noise, anytime the height above ground is, ridiculously high, so that's over 100. I'm assigning a 3 anytime the height above ground is less than 100, so that's 3 is a building, and the classification is 2. Is not 2. And then I'm assigning a 7, which is low noise anywhere where the height above ground is less than -10. So these are sort of conservative values. You can play around with those for sure. The next thing is it calculates how planar the features are, and what this is intended to do is feed into a building classifier. So based on that approximate coplanar attribute, which is 1 when it's coplanar and 0 when it's not, it will assign. It calculates that. It calculates a variable called coplanar, and then it's going to assign. Actually, 6. I think I misspoke earlier. 3 is vegetation, so that's what's going on earlier. 6 is a building. So it's setting these to a building wherever there's high, wherever it's pretty high as the coplanarness is very high. I'm looking at this now too, and I'm seeing and the classification is not equal to 2. That's right. So the reason I had that set was a lot of times the ground is pretty flat. So if you don't do that, you're going to reclassify a bunch of your ground as buildings. The idea for this kind of came from one that was posted by Bradley Chambers, who's one of the co-authors of PDAL. I've added this to the wiki. I posted a link to this particular JSON file. I really, really dig this syntax. I think this is kind of perfect as far as it goes for LiDAR processing. I'm really excited to see this. This makes sense to me. It's not irritating to use. You don't need to go into Python to do it. I think this workflow is going to work really well for us. This is an example of what that looks like. No classifier is perfect, and this is no exception. So you can see that the colors are sort of don't correspond to anything, but you can see the differences in classification. So blue is ground, this orangish color is a building, the greenish color is vegetation. Broad strokes, this does pretty well. You can pick out a couple of spots where it definitely doesn't. The edges of buildings are particularly prone to being misclassified because those are not planar, right? They're edges. So maybe we can add something like an edge filter and look for places that are sort of particularly steeply edge-like, and then call those buildings. I don't know. We'll have to play around with that a little bit. But I think that this looks really good as a baseline. All right. As usual, lately, most of my time is spent on the build project. The big kind of higher level summary is here. Even too much to get into a lot of these details, unfortunately, because I would like to commit these to the log. But we did get the GeoSLAM data in. I'll show some images of what that looks like. We got an 11th sensor placed in front of the vestibule entryway, and it's been configured. The iCat Linux machine is running Percept. We migrated things from the Windows machine to the Linux machine. I do think it probably runs a little bit more smoothly. I'm not convinced it runs fast enough. We keep hitting this roadblock with that, and if we do that, I'd almost rather just run this on a Windows box, honestly, because I'm a little more familiar with Windows, and so I feel like I'd be able to get things running faster than having to sort of hammer around Linux and figure things out. But it doesn't matter. It's all running fine. So that's fine. I got Anaconda installed on the Linux machine, so it can run some Python scripts, which I have done. I run some of the Python LAS file logging on that. The LAS files are getting logged every 10 seconds. I don't think I even had this accomplished last time, but I've got the PDAL stuff written out. This was sort of the recipe for PDAL earlier, was to get this working. So that's working well. We're looking at 1,500 kilobytes per file. That amounts to about 12 gigabytes per day. I'm also logging images, including the max return intensity every 2 seconds. I don't know that I need both of those. They're pretty redundant, but at this point we don't really know what we need. I've had this pegged at 1 second. You can see that's going to really jump our storage requirements. I haven't done the math on this lately, but I think we're coming in under something like 20 terabytes a year for all of this data. That doesn't include the data coming out of Outsite, not Outsite, Percept, which is likely another 10. So we've got pretty steep data requirements on this project. That's a ton of data. How we're going to process that all in a reasonable fashion, I'd have no idea. It's not so much data that we can't. It's a lot of data. So yeah, we'll see. I'm going to present these out of order. I met with the Percept engineer Axel Mueller, as well as Snehal, who's been our point of contact at Blickfeld. So one thing is that with the people, he suggested that if we're using the dynamic background, then we should set the exponential decay function lower by an order of magnitude. So the default is 0.005, and I've now set them all to 0.005. So that's a lot lower. I haven't really evaluated how well that's working. The other thing is that we talked a little bit about how to use the static function. What that does is it captures a number of frames that you specify, by default 10, and it uses that to form a background image, and then it basically uses that for the detection. These things are, so an example of this is in the lower right. They come in per sensor. They're stored with the data files in the Blickfeld data folder. And they are, they're logged, they're stored as .bin files, but they're actually PCD files. So this is great. I was going to get a screenshot of this. I looked at the binary data for that and saw right in the header that it's actually a PCD file, so that made my life super easy. I just put a PCD extension on the end of them and dragged them into Cloud Compare, and they loaded right up. I think they look neat. There's a little bit of jitter in this instrument, and so it's neat to aggregate on 10 frames anyway. I think this looks gorgeous. And the best thing about it is that we can basically edit these directly and then supply something different as the background. So we can, for instance, manually edit out those tables and then upload them again. And then theoretically, anything that isn't there should show up as an object, which means we can track all of the furniture and everything else. Super exciting, I think. Lots to do, and in fact, some of this stuff I've already done already. I will fold them into the next bit of this here. So we need to figure out how to keep Percept on the local machine only. It is currently opening up its interface to the world and the local network. We really only wanted to open up to the local network, so we have to figure that out. I've been banging around on that for many hours, trying to use the UFW, which is the firewall for Linux, to do it. I've been trying to change the compose, docker compose.yml file, and specified a network file or a network bit of that. Haven't figured it out, so I don't know. I've emailed Blickfeld about that. I want to get XRDP or X11 tunneling through SSH on that machine so that we can remotely log in a reasonable fashion. Of those two, I'm starting to think that tunneling through X11 is the right way to do that. One less thing to worry about. We're getting a lot of echo on the images on the LAS backups. I'll show what this looks like on the next slide. Essentially, the data that we're pulling. So we're logging each LiDAR frame composite every 10 seconds. And what we're finding is that those individual, we've got 11 sensors up and they're not temporally aligned. So that's an issue. I'm not sure what's causing it. I guess I'll get into that on the next slide. And then I need to spend a little bit more time evaluating the Percept logs. Again, I've actually done some of this, so I will present some of that next time. Essentially, they come in as JSON files, and I've got some code written that will take those apart. So we can start looking at the tracks. Things look pretty good there. I'm excited to see that. This is what the GeoSlam data looks like. Not the best view. This is so they did a great job. This is Todd Ogle's Aries lab. Sarah Tucker and her team, another Sarah and Katie, did the scan and they're processing it. The sort of rippling effect on the floor where there's all these little overlapping circles is weird. I've emailed them about that. Spatially, I think this looks pretty good, but the RGB texture, which is pretty new for them, is not so great. This is what the exterior looks like. I think this is great. We're getting a ton of the facade of the building, which we kind of need to situate this in real space. Not that that's a huge concern, but just for context. Yeah, you can see that rippling effect on that front facing sidewalk too. So weird. Hopefully they'll diagnose that and get back to us on that. I also added the point ID source to the LAS output. I was pleasantly surprised to see that this didn't add any data to the file. I suppose they have to use those bits anyway. I wonder if there's a way to store this in a different point format that might be smaller. I will look into that. Maybe it's storing this in a way that could be much smaller. That'd be great. I'll do a little looking. See, this is why these things are good. I get things all the time. So this is the point source ID, and now we can see which points come from which sensor. Logged by IP number, so 101 to 112. Okay, echo and images. Let's take a look at this. So the idea here is that we've got this temporal misalignment in the data, and let's just play a little section. So this is a intensity layer. You can see that we've got pretty good coverage, some coverage better than others. So what we're looking for as this runs is sort of all of these different, things that move together that are the same person, shown as different blobs. So, I really don't know what's causing this. I wish I did. I got to thinking today, in the short run, it's not such a big deal because, if our first cut is just sort of occupancy, the temporal delay will just wash out when we aggregate. But we'd still like to get this fixed. Now, when I say there's no idea as to the cause, I guess we can say that there's some things that we don't think it is. So I've spent some time looking into this. And I mean, one of the things that seems to be happening is, when we're synchronizing the time. I actually revised this a little bit because it looks like that time.sleep statement at the bottom is one block too far in. But ideally, these things are they're all synchronizing their time every half an hour. I used to do them one at a time. Now I'm trying to do them all at the same time. Time synchronization on these things is a little weak. It takes a lot longer than it should. It fails more often than it should. I'm not sure why that happens. Anyway, we don't really know what's going on with that, and we have some work to do to try to figure that out. In looking for that, I wrote this code, which essentially pulls each stream, pulls its data down. It marks its own timestamp as we pull the time in. And so we can compare both the time that's attached to the frame, so what the device thinks the time is, with our own system clock. The bottom there, what you're seeing there is a look at what times the system thinks it is, and they are all the same. So that's pretty weird. They seem like they should be aligned. They're still not aligned. I don't know. Still playing around with that. In terms of my own system time, we pulled the first one, we logged the time. We pulled the 11th one, we logged the time. We log all of the times for all 11. And the difference between them, between the first one and the last one, is usually pretty small. It's often 0.01. It's usually it can be as low as 0.01. It's often 0.1. I've seen it as high as like 0.3 or even 0.5, which is definitely too far. So when those numbers are like 0.3 and 0.5, you can definitely expect an echo. And even at 0.1, that's probably more than we'd like to see in terms of a time separation. 0.01 shouldn't be too bad at the rates that most people move around. So I don't know, still up in the air. I've got an email to Blickfeld about this, and we'll keep poking at it. Object tracking. I don't have a slide on this, unfortunately, but one of the things that I discovered, I'll try to put this in maybe at the next one. But one of the things that I discovered is that the project with 11 sensors is, it's not, how do I put this? It is only logging a frame. It's highly variable. Best case scenario, it's every 10 seconds. Worst case scenario, it's a couple of minutes. So when I spoke with the Blickfeld people, they had assured me that what we're seeing in the visualization is not reflective of how well the algorithm is performing in the background to track objects. That turns out not to be true. It definitely is affecting that. So So the object tracking with 11 sensors is totally not working. I am currently trying running each sensor independently. That's not ideal for a number of reasons, but if it makes for a better cloud, then that's fine. I'm really surprised that more sensors has caused this much of a problem. It really should be fusing that data right away, unless it also has this temporal jitter that's given it fits. So I don't know, it's weird. All right, last but not least is a little bit of Carta experimentation. I don't even have the results of this here, but just as a preliminary, you can. So Carta is a company behind the Loam algorithm for SLAM for LiDAR sensors. I was chatting with Paige Williams in the remote sensing IJEP, and she has apparently they've got a raw Velodyne puck on their drone, and it's pulling and logging straight PCAP data, which is point capture data. It's like raw traffic right off of the sensor, and they don't know what to do with it. What they need to do with it is run a SLAM on it, and there aren't a lot of great solutions for this. I was reminded that Carta should be able to do it for free, at least as a test. The rates are, in my opinion, pretty reasonable. It's like $5 per gigabyte for real payment. You know, if it works, it's worth it for sure. So I wanted to give it a try. So I logged in and I created an account and I uploaded some sample data that I gathered with the Velodyne last year, 2 years ago, a while ago, and we'll see how it goes. All right, so that's it for me. Hopefully we'll see everybody at the next meeting live, and we'll see everyone again soon. Bye.